Namaste. Let us discuss what are resemblances and differences between hydrogen and halogens. So in this video, we are going to see what are the points of similarities as well as the point of differences which are present between hydrogen and halogen. So what makes it possible for an hydrogen atom to be placed along with halogen? So the very first point which I'm having, that is electronic configuration. That is electronic configuration. So just like your halogen atom, hydrogen atom also possesses one electron less than the nearest noble gas or inert gas element. So I have a fluorine, atomic number 9, electronic configuration 27. I have a chlorine, atomic number 17, electronic configuration 287. Now fluorine has got one electron less than the nearest noble gas, that is neon, electronic configuration 28. Chlorine has got one electron less than the nearest noble gas, that is argon, having electronic configuration 288. Now if I take hydrogen, which has got atomic number 1, electronic configuration 1, has got one electron less than the nearest noble gas, that is helium, electronic configuration 2. Electronic configuration 2. So here I observe that the number of electrons present in the outermost shell of halogen is less than the number of electrons present in inert gases by 1. Okay, so same is been possessed by hydrogen. So that's the first point of similarity between hydrogen and the halogen. Now, the second point, that's the formation of ion. As we have seen earlier, halogens have got 7 electrons in its outermost shell, so they tend to complete octet, or they tend to attain octet by gaining one of the electron. So here, like halogen, hydrogen also shows a tendency to gain one electron so as to form negatively charged ion over here. So let me take fluorine, atomic number 9, electronic configuration 27. So fluorine gains one electron and gets converted into F-1 ion, that's fluoride ion, has got electronic configuration similar to that of your noble gas, that's neon. Then I have a chlorine, atomic number 17, electronic configuration 287, will gain one electron and gets converted into chloride ion and attains electronic configuration of nearest noble gas, that's an argon. Now hydrogen has got one electron in its outermost shell, so it has got 1, will gain one electron and gets converted into H-1, which we commonly call it as an hydride ion, commonly known as hydride ion, and attains the electronic configuration of nearest noble gas, that's a helium. So here, like halogen, hydrogen also shows a tendency to gain one electron and attains stable electronic configuration of nearest noble gas and forms negatively charged ion, which is commonly known as anion. The next I am having the physical state. So as you see, fluorine is a gas, chlorine is also a gas. So hydrogen is also a gas, we can say. So when I talk about halogen, like I have fluorine is present as a gaseous state, so it's a gas. Chlorine is also a gas. Bromine is a non-metal which is found in liquid state. And iodine is found in solid state with metallic luster. Now hydrogen shows resemblance with the fluorine and chlorine in terms of gas. So hydrogen is also gas, but solid hydrogen resembles iodine. So solid hydrogen resembles iodine. So this is in terms of their physical state when they are present. Like next we have about physical state. Next we have about physical state. Now next we have after physical state atomicity. Atomicity is nothing but a number of atoms present in a one molecule. So like halogen which are diatomic, hydrogen is also diatomic molecule. Hydrogen is also considered as an diatomic molecule. So I have fluorine as an F2, chlorine as Cl2, bromine as Br2, iodine as I2. So likewise, I am having hydrogen as H2. Hydrogen as H2. Then next we have, this is about atomicity, that is number of atoms in one molecule. So like like halogen, hydrogen is also diatomic molecule. Hydrogen is also diatomic molecule. Now next part we have reaction with metal. Reaction with metal. So generally it's been seen that like as your halogen tends to combine with active metal like sodium, potassium, calcium, magnesium, they results in a formation of compound which are found to be ionic or electrovalent in nature, which are either ionic or electrovalent in nature. So here we have hydrogen also when tends to combine with this active metal, it results in formation of corresponding hydride. It results in formation of corresponding hydrides, and those hydrides are also ionic or electrovalent in nature. Like I have sodium metal combines with chlorine in order to give me sodium chloride. In order to give me sodium chloride. So to balance this, I'll multiply here by 2 and here by 2. Now your sodium chloride is ionic in nature. Sodium chloride is ionic. Okay, sodium chloride is, we have ionic in nature. Now let me have sodium metal combines with hydrogen, results in formation of sodium hydride. Results in formation of sodium hydride. So this is sodium hydride. Okay. Now this sodium hydride is also ionic in nature. Sodium hydride is ionic in nature. So as active metal combines with halogen, the compound form is ionic. So hydrogen also do combine with those active metal in order to give an ionic compound. So these were the points of similarities which is present between your hydrogen and halogen. Now let us focus on the point of differences which are present between hydrogen and halogen, the hydrogen and halogen. So we have number of shell, we have number of shells. Like as we have seen in the electronic configuration, the halogen which are there, the halogen which are present, they possesses more than one shell. They possesses more than one shell. That means fluorine possesses two shell, chlorine possesses three shell, bromine possesses four shell, like that. But if you see a hydrogen which has got only one shell is present in case of hydrogen. So that's the number of shells as a point of difference. Then next we have nature of oxide. The nature of oxide. Now the oxides of halogen, they are acidic in nature because halogen is a non-metal. But whereas oxide of hydrogen, it's neutral in nature. Oxide of hydrogen, that is neutral in nature. So let me take oxide of halogen, that is Cl2O7, which is called as chlorine heptoxide. Now, when you dissolve this in water, it will give me corresponding acidic solution. Apart from that, it will react with base so as to give you, or it will react with alkali so as to give me salt and water. But on the same ground, if I am having the oxide of hydrogen, that is water, so it is dihydrogen oxide, which we call it as an water, and we know that water is neutral in nature. Water is neutral in nature, and this is found to be acidic in nature. So we have oxides of halogen are acidic, whereas oxide of hydrogen is neutral. The next we have electronegativity. Now we have discussed in our previous sessions, when we discuss about periodic table, we come across a term electronegativity. Generally, halogens are electronegative in nature. So halogen shows a tendency to attract shared pair of electron towards itself. So it's an electronegativity is nothing but tendency of an atom to attract shared pair of electron towards itself in a covalently bonded molecule. So generally halogens are electronegative, and we know that fluorine is most electronegative atom. Fluorine is most electronegative atom. So, but hydrogen is not electronegative. Hydrogen is not electronegative. So these are the points of differences present between halogen and hydrogen. So in this video, we have discussed about what are the points of similarity which are present between halogen and hydrogen, and what are the points of differences present between halogen and hydrogen. Thank you for watching.